Today we're going to look at linear regressions. We already know what's linear equation from other sections, the standard form of linear equations. And we also seen the slope-intercept form, right? And this is the slope-intercept form. And when we draw the linear equation, we know that linear equation always give you straight lines, right? Using the previous information that we have, we're going to look at the linear regressions. So example 1, this is the data, right? Time, so T is for timed in a weeks, and W is for the weight in a pound, right? With the table or given information, the first thing they're asking you to do is draw the scatter plot. So what better ways to look at the data or trying to characterize data by graphing it, right? And that will be the one way of doing it. And this is one type of graph. So I'm going to show you how you're going to draw data into scatter plot. So first thing we need to do in order to draw the scatter plot is setting your rectangular coordinate systems. So the cross is going to be your times, right? And going up will be your weight. This is going up, your weight. I kind of short it down because your weight is way above 100, right? 196, 192. So I put it all there on top. And what we're going to do is plotting all this data. So when it's 0, it was 196. 196 should be somewhere between 194, 198. So when I mark it, it will be somewhere here in between. And when it's 1, it will be 192. So that's going to be between 190, 194. So somewhere right here. And 2, it will be 193. 193 will be right under 94. 190, so that will be somewhere right here. 4 will be 190 also, and 5 is 186. So looking at these dots, it looks like it's going to be linear, right? Long as your line, if you can draw the straight line between those data points, and it's not too far away from that straight line, it's not going to be exact though, right? Then this is going to be linear. So then, let's see if we can find B, trying to find the regression equations from the given data. In order to find the regression equation, there's several ways of doing it. The method that I'm going to show you here is going to be doing it by hand. And when we wanted to do that, we wanted to find certain values. So the first thing we wanted to find is multiplication of those data. And we're going to say X is going to be times, Y is going to be weight. So X times Y is what we wanted to find. Also, we wanted to find X squared and we wanted to find Y squared. Why do we wanted to find this? So if we wanted to find equations, the reason we're looking for all these points, X times Y, X square, Y square, all that, is because if we have y equals to bx plus a, which is the linear equation's slope-intercept form, where this a value right here should be able to find it using this formula right here. And this is the formula to find linear equations, right? The a part, which is the slope, vertical changes, right? Vertical intercept is going to be this formulas. B, which is your rate, slope, is going to be from these formulas. So using those two formulas, we should be able to find linear equations. In order to use that formula, we need to find x squared. That's where we have there. And then we will need the x times y and x squared again, right? All this is what you're going to need it. So we're going to fill this part. Your y squared, you're going to need it for later in different section. But we're going to find those informations right now. Okay. So how are we going to find x times y? Well, you just multiply this 2, right? So when you multiply that 2, you're going to get 0. 0 times any number will be 0. And this is going to be 192. 2 times 193 will be 386. 3 times 190 will be 570. 4 times 190 will be 760. 5 times 186 is going to be 930. And let's see if we can find the sum of those numbers also. This symbol is summations, so you're going to add them up. So you're adding 0, 1, 2, 3, 4, 5, you're going to get 15. When you add all the weights, you get 1, 1, 4, 7. So in other words, this is going to be a total, right? Adding x times y will be 2,836. X squared, let's find x squared first. So 0 squared will be 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. When you add them up, you get 55. Y squared, 196 square, you get 38,416. 192 square, 36,864. 193 square will be 37,249. 190 square is 36,100. Same thing on the bottom. And then 186 square will be 34,596. And we add them up, we get 219,325. So with that number, let's see if we can find A first, right? So in order to find A, you're going to start by summation of y. So summation of y will be this number times x squared. So x squared will be right here, right? Summation of x squared minus x, that's 15. That's 15, right? Summation of x. Summation of x, y. X times y will be this number. And then n will be number of the data. So how many datas you had? 1, 2, 3, 4, 5, 6. So n becomes 6. This is going to be summation of x squared again. Summation of x squared minus summation of x. Summation of x squared. So you're going to square this number, which is going to give you 225, right? So I'm going to write that down. Summation of y, 1147 times summation of x squared, 55 minus summation of x times summation of x times y. all over n is 6, number of the data again, and 55 minus 225. And when we plug in the numbers, your numerator, you end up getting 20,515, denominator 105. This will give you, if I round to the nearest hundreds, I get 195.38. So that's going to be my A value. This is going to be my A value. Let's see, using this formula, I'm going to find my V value, right? So find my V value by plug into the formula. N is 6, summation of x times y, minus summation of x, summation of y, all over 6 times summation of x squared minus summation of x, which is going to be 15. You square that, you get 225. And this gives you negative 177 over 105. Again, if I round this to the nearest hundreds, I get negative 1.69. So if we wanted to plug in this into the equations, y equals to, your b is going to be negative 1.69x plus your a will be 195.38. So that's how you can find your equations, linear equation from the data by hand. You can also do this using decimal or any other tools that you can use it in a computer system, right? And the C is asking you to interpret the meaning of the vertical intercept. Remember which one was vertical intercept? When you're looking at the linear equations, plus A was the vertical intercept, which is y-intercept, right? So from the equation you found, 195.38 is going to be vertical intercept. And what does that mean? It means when x is 0, your x is time. So when there was a 0 times, so when you're starting it, the person will have 195.38 pounds to start it, approximately, right? Because we were rounding the number before. So that's the value it's starting. So when x is 0, this is going to be the value you're going to get. And since here x is times, 0 times, very beginning, this is the weight stay starting. That's what it means on the C. And then D is asking to interpret meaning of the slope. So we need to know which one is the slope. Remember B, the number in front of the variable x is going to be slope. So this one have negative slope. It means it's decreasing, right? So weight is going to be this decreasing. X is the time, so it will be, decreasing this amount time each week. So each week, the weight decreased by approximately 1.96 pounds. Now, E is asking to use these equations to predict the weights after 2.5 weeks, right? And then do the same thing for F, but it will be 6 weeks. So all you need to do is changing this X value. 2.5 weeks, you're going to replace X with 2.5. 6 weeks, you're going to replace X with 6 weeks. So let's try those two. So E, 2.5 weeks replaced by X. When you plug in those numbers, you will probably get close to 191 pounds. And then F, when you're replacing X with 6 weeks, you're going to get close to 185 pounds. What about the last one? When we go back to the problem and look at the last, it say, what about after 100 weeks, right? So we're going to figure that one out with the 100 by replacing X with 100. When you replace X with 100 with the same rate, you end up getting 26 pounds. And they're asking why this is not possible or not possible, right? And finding this, I will say this is not possible because individual weight cannot be 25 pounds, the adult, right? This had to be really, really small baby. It means that you're not going to lose your weight after the 100 weeks with the same rate. The weight will get slowed down. Your weight will get smaller each week. You don't lose the same weight every week, right? Because it looked like if you lose weight in same rate, even after 100 weeks, you're going to disappear. And that's not possible, right? And that's what they wanted to know, if you can see that from this data. Next example, they have the data given again, right? Different data given again, and they want you to draw the scatter plot for the given data. And they wanted to know if it's increasing, decreasing, and they wanted to know if the data is going to be a linear, right? So let's draw the scatter plot first. So when you draw the scatter plot for the given data, this is pretty much what you're going to get. And if you wanted to answer if this is increasing and decreasing, because the value is keep going up, value is keep going large, it's going to be increasing. And if you wanted to know if this is going to be linear relationship means you're going to have straight lines. Again, look like you're going to have a straight line, right? So that's, yes, you're going to have linear relationship on this one. Example 3 is asking you to find the linear regression equations. So in order to find the linear regression equations, remember we're going to use the formulas. So in order to use the formula, we need to know what will be x times y value is, what is x square is. We don't get to use y square yet, but then you're going to use that later, so we're going to figure that one out also. Okay, so I have here this formula. This is a linear equation in slope-intercept form, where this is going to be intercept, your b, and this is the formula you're going to use to find your y-intercept or vertical intercept. Your slope rate is going to be formula right here. So in order to use all this formula, you need to know these values. So what I just did right now is putting my x value vertically, your y value vertically, right? So I'm going to first put your summation of x, means you're adding them up. You get 42. When you add them up, x value, you get 182.61. And when you multiply x times y, 0 times any number will be 0. 2 times 24.78, you get 49.56. 4 times 25.93, you get 103.72. Next number, 157.44. 8 times 26.93, you get 215.44. 10 times 27.04 will be 270.4. 12 times 27.93 will be 335.16. When you add them up, you get 1131.72. X squared, 0 squared, 0, 2 squared, 4, 4 squared, 16, 6 squared, 36, 8 squared is 64, 10 squared, 100, 12 squared, 144, right? Y squared, you should be able to use your calculator. You get 564.54, 614.05, 672.36, 688.54, 725.22, 731.16, 780.08. And make sure you put all adding the data of that vertical line. So you're going to use those summations of number. So if we wanted to find B first, which is a vertical intercept, you're going to do summation of y. Oh, make sure this is y, right? Summation of y time summation of x squared minus summation of x times summation of x times y over all over number of the data. You have 7, right? And times 365 minus 42 square. This gives you 19,120.41 over 791. When you divide this and round it to nearest hundreds, 24.17 is what you're going to get. Now let's find the slope. 7 times 1131.72 minus 42 times 182.6 all over 7 times 365 minus 42 square. Well, this one will be close to 0.32. So the equation is going to be y equals to slope. This is positive slope, right? Plus 24.17. So that will be the equations for example 3.